All right, good morning, good afternoon, good evening. We're going to start talking about 6.7a, solving equations using the zero product rule. So 6.7a is kind of the culmination of why we are doing factoring, because we will be given essentially at some point a quadratic, maybe equation, likely equation, and we'll have to find the values that satisfy the equation. In other words, solve that equation. When we solve the equation, you got to tell me what x is equal to if we're using x as a variable. So we're solving equations using the zero product rule. We're going to first of all, I guess, define quadratic equations, then define the zero product rule, and then use it. So let's go over here and say, there's our presentation, solving equations using the zero product rule. We're going to do a couple of these right in the video. Definition of a quadratic equation and the zero product rule, and kind of use a couple of different examples in this video, and then probably do a couple more examples in another video. Alright, so let's find out what a quadratic equation is. What is the definition of a quadratic equation? And I would say if you're coming along with the cheat sheet or study guide, add this to it. Let's go back a couple of chapters and talk about linear equation. Linear equation is the form ax plus b equals 0. The equation part comes in with the equal sign. Linear part comes in with the x to the first power. There's no first written there, but we have to write it down there. Highest degree is 1. It's kind of similar to y equals mx plus b, because we've got an equation, we've got an equal sign and an x to the first power. With a quadratic equation, the quadratic part comes in with x squared. When you see an x squared term in your equation, then you've got a quadratic, and the equation part is just the equal sign. So for the equation means we've got an equal sign. So when you've got an x squared term as the highest degree term, then we've got a quadratic. If we've got an equal sign as well, then we've got an equation. So what's a quadratic equation example? Well, here's one. X squared term is right there. We've got an equal sign. So sure enough, that is a quadratic equation because the highest term is a squared term, and there's an equation. This as well is a quadratic because x times x minus 2 gives us x squared minus 2x, and then equals 3. We've got the quadratic part right there. We've got the equation right there. Same thing right here. We've got to use that dreaded F word, and we say if we FOIL this out, in fact, we probably don't need to FOIL this out. We could, but we don't need to because we can recognize from, I think, the previous section that x minus 4 times x plus 4, or x plus 4 times x minus 4 gives us x squared minus 16, and then equals 0. So again, quadratic equations. So all these are quadratic equations. We've just got to pay attention to what we've got and solve accordingly. All right, so that's a quadratic equation. What's the zero product rule? One more thing, I guess, to remember, a zero product rule. We're going to add this to our cheat sheet or study guide. Remember, you won't be able to use that in the test, but you'll be able to study from it. So this is really kind of the reason that we've been working on factoring polynomials so much, because now in previous sections we've factored polynomials, and a polynomial is just an expression. There's no equal sign at all. We've been looking at things like x times x minus 3. How do we factor that? Well, it's factored already. How do we factor something like x squared minus 16 in the previous slide? How do we factor this? X squared minus 16, it was x plus 4 times x minus 4. And we've kind of gone from here over to here without the equal sign. This section introduces the equal sign as a way to introduce quadratic equations. And now we can factor one side as a polynomial by listing the factors of the polynomial, and if that polynomial is equal to 0, as is the case now, we're going to add that part here, or we're going to rewrite that. I hate to use the word add in mathematics, but we're going to have now equations like this with the equals 0 on one side, and then we can use the zero product rule. So what is that right here? I would say, take a look at this. Here's our zero product rule. If a times b equals 0, then either a is equal to 0 or b is equal to 0. Now let's take a look at that. If a is equal to 0 over in this equation, 0 times whatever b wants to be is still going to be 0. 0 times 15, 0 times a million, still equal to 0. Same thing holds true for b. If b is equal to 0, then b times whatever a wants to be is still equal to 0. 0 times a million is still 0. So there is our zero product rule. So the important thing is we're going to have factors over here. We've got to have an equals and we've got to have 0 in order to apply the zero product rule. So let's take an example. Here's a factorization here, and here's an x minus 4 times x plus 3 equals 0. If here's my a, and here's my b, then a times b equals 0, and either a is equal to 0 or b is equal to 0. And what I'm going to do is say, solve this equation for x. When I say solve the equation, I say, what is x equal to? And essentially we have to say, we've got x minus 4 equals 0, or x plus 3 equals 0. Because that's the application of the zero product rule. Either a is equal to 0, a is equal to 0, or b is equal to 0, b is equal to 0. And then we solve these mini equations. We've got to say that, well, we've got to add 4 over here, add 4 over here. We've got to keep the kids happy at Christmas time by keeping both sides equal. And we get x equals 4, or subtract 3 here, subtract 3 here, just by one-step equations here to solve these by, here's our one step, subtracting 3 from each side, and we've got x equals 4 or x equals negative 3, and we can double check by going up here and say 4 minus 4 is 0. That's correct. So 0 times whatever that wants to be, it happens to be 7, but 0 times that equals 0. So that works. Negative 3, if this is negative 3, if x is negative 3, negative 3 plus 3 gives me 0. As b, our a term can be whatever it wants to be. It happens to be negative 7. But 0 times whatever it wants to be is equal to 0, so we're okay. Alright, so pause the video and do this one on your own. Alright, did you get the solution of so this has been factored already, equals 0, it's a quadratic equation. So we've got to say, here's our a, here's our b, and either a is equal to 0 or b is equal to 0, so x plus 1 equals 0, or x minus 8 equals 0. Solve the mini equations by adding 1 here, add 1 here, add 1. And we get x, subtract 1. Subtract 1, and subtract 1. Boy, that's a mess. Sorry, we subtract 1. And we get x equals negative 1. And over here we add 8, and we add 8. We do add 8, yes. X equals 8 is our solution over here. We can double check by going back up here to our original equation. Negative 1 plus 1 equals 0. 0 times whatever it wants to be. Yep, sounds good. X equals 8. 8 minus 8 is 0 for b. 0 times whatever it wants to be is 0. So that one's okay. So there's our two solutions. And if I say solve these equations, then you got to tell me x equals something. All right, let's go to the next slide. Use the zero product rule again for these. These again are just making things a little bit more challenging, but just a little bit different. Here's our a, here's our b. A times b equals 0. Either x equals 0 or 3x minus 7 equals 0. Now, for this one, x equals 0, you can't get any simpler than that. So either x equals 0, or solve this one by doing a two-step equation by adding 7 to each side. We get 3x equals 7. Divide by 3, and we get x equals 7 thirds. So let's double check. If x equals 0, 0 times whatever it wants to be, yep, sounds good, equals 0. X equals 7 thirds. 7 thirds times 3 is, oh my god, fractions, yes. 7. 7 minus 7 equals 0. There's 0 times whatever it wants to be equals 0. Yep, so that's good. All right, for this one, pause the video and do this one. We'll come back real quick. All right, if I've got this one here as an A and a B, and you know what? I'm going to have you guys do this as homework. So there you go. Do that as homework. Make sure you're taking notes. Add that homework question to your notes, and then add it to my Dropbox. We'll keep going. All right. All right. So far we've been given polynomials over here that have been already factored, but the next step is to make things just a little bit more complicated. And what we have to do is make sure that one side is equal to 0. So here's the steps for factoring for solving a quadratic equation. Essentially what we're going to do is we're going to write the equation in the form ax squared plus bx plus c, everything on one side, and then equals 0 on the other side. So there is, I'll put that equals in circle. Everything on one side equals 0 on the other. And then on the left side, factor that red quadratic equation completely. How do we do that? Look at section 6.1 through section 6.6. Factor out a greatest common factor, put it in descending order, factor out a -1 if we need, and then use all the tools that we've learned, either trial and error method or AC method, or recognize that it's a a difference of squares or a perfect square trinomial, something like that. So factor is section 6.1 through section 6.6. And then step 3 is apply the zero product rule after you've got this factored. And then, which means, set each of those factors equal to 0 and then solve the resulting mini equations. So let's take a look at some of these. So I'm going to say my question is solve these quadratic equations. That means that x equals something, or whatever your variable is. Down here the variable is y. Over here it means solve this equation, means tell me what x is equal to. Now before we move on with this one, I'm going to say that we cannot use this. Please note that we cannot use this approach. That, let's see, we're going to factor out an x, and this gives us as 2x minus 9 equals 5. So either x equals 5 or 2x minus 9 equals 5. Cannot use that approach because it's not the zero product rule. The zero product rule states that everything on the left side equals 0, or everything on one side equals 0. When it's equal to 0, then you can use the zero product rule. If it's equal to 5, you can't do it. Just note that that one there, don't do it. All right. So now, that said, I'm going to go up here and say, you know what, let's not do that. And we'll say, let's figure out how we can do it. All right, remember our zero product rule says, or to solve these, the steps to solve the equation means put everything on one side, 0 on the other. So what does that mean? We've got to move that 5, subtract 5 from the right side, subtract 5 from the left side. What do I have? 2x squared minus 9x minus 5 equals 0. And yes, that is a squared term. All right, so now that we've got everything on one side equals 0 on the right side, now we can start factoring on the left. Because when we factor on the left, we can put one of those factors equal to 0. One factor equals 0, or the other factor equals 0. But now we've got to factor this. Remember in one of the sections we talked about how to differentiate between approaches to take. For this one, we're going to say let's approach this using one of the methods. So now that we have everything put on one side equals 0, we can use the zero product rule to factor the left side as a quadratic expression, and then if it's equal to 0, then a is equal to 0 or b is equal to 0. So if we take a look at 2x squared minus 9x minus 5, our thought process was, how do we factor this out? We can use the AC method. We could use a times c equals 2 times minus 5 is negative 10 and find factor pairs and da-da-da. But you know what? Because 2 is a prime, 5 is a prime, the only thing that really kind of throws us might be this minus sign. But let's try to use our factorization of trial and error method and say, well, you know what? Here's my x. Let's set up our skeleton here. There's an x and there's an x. 2 factors into 2 and 1. All right. Green, please. 2 factors into 2 and 1. All right, so green here, there we go. 2 factors into 2 and 1, so we can put 2 here and 1 there because we're factoring a into these spots here. And now we got to play with 5 and say that 5 factors into, actually negative 5 factors into negative 1 and negative 5. Or sorry, negative 1 and positive 5, or positive 1, negative 5. So let's just play around with those two here and see what we can get. Well, I know I've got to sum up to with the inside multiplication and the outside multiplication. We've got to add up to negative 9 because those combine with our FOIL method to get to that negative 9x. So if we put a negative, we've got to get to negative 9. I'm going to try putting negative 5 over here because I think this is going to be a good factorization. Negative 5 and positive 1 over here because they would multiply together to get me the negative 5. In our FOIL method, this would be the last multiplication. Plus 1 times negative 5 is negative 5. If we add up the inside and outside terms, we would get inside would be plus 1x. Outside term would be 2x times negative 5 minus 10x, which adds up to negative 9x. So that's a good factorization. So we can go through the full FOIL method and say 2x times 1x, 2x squared. Inside and outside terms, would be inside terms plus 1x, outside terms minus 10x. They add up to or combine as like terms to get to minus 9x. Last term plus 1 times minus 5 is negative 5, so that's a good factorization. So now, using the zero product rule, we can say that either A over here is equal to 0, or B over here is equal to 0. So I would say that either 2x plus 1 equals 0, or x minus 5 equals 0. And I'm going to simplify this just to come, we don't have to write that 1 down here. It could be 1, we could write 1x, but it's simpler to write just x. So now we can solve these mini equations and say, you know what, add 5 to this side, add 5 to that side. And what do we get? X equals 5. Or 2x plus 1 equals 0. This is a two-step equation because we've got to subtract 1 over here first. Subtract 1 from each side, and that is a 1. I started to write the 2. We get 2x equals negative 1. Divide by 2, and we get x equals negative 1/2 just by dividing by 2. Alright, so now we can go back to our original equation, this factorization, because we did double check our factorization here to get here. So we would say x equals negative 1. Negative 1 times 2 is negative 1. Or sorry, negative 1/2 times 2 is negative 1. Negative 1 plus 1 is 0 for this factor. 0 times whatever this wants to be is 0. So that checks out. X equals 5, is that a solution? If x equals 5, then 5 minus 5 is equal to 0. So that factor is equal to 0. 0 times whatever that wants to be is 0. So that would be a correct factorization as well, or that would be a correct solution. So there's our two solutions. I'm going to ask you now to take a look at this one and say, do that one on your own. When I ask you to pause the video, do that one on your own, very similar to this one, but we're solving now for y equals something, only because we're using y here. And we are looking at this and we're saying, can we factor it? Yep, we've got a quadratic, because the highest term is a squared term, equation, equals sign, so we're okay. So pause the video, work on it yourself, see what solutions you get, and double check your work, and then we'll get back together. Alright, now we've got, again, a quadratic equation. The highest term is a squared term. Highest power on the highest term is a squared term, and equal sign is there, so we've got a quadratic equation. What we need to do is use the zero product rule to say that one of these is equal to 0, or one of the factors on one side is equal to 0, but we cannot. Let's take a look at this just for fun. We cannot start this way, and I'll repeat. Don't do this. Don't say, oh, 2y squared plus 19y, I'm going to factor out a y, and I got a 2y plus 19 equals negative 24, so that y equals negative 24, and I'm going to write real sloppy just because this is not the way to do it, or 2y plus 19 equals negative 24. Don't do that, because the zero product rule says that you've got to have this equal to 0. Alright, so don't do that. You've got to make sure that everything is equal to 0. How do we do that? Well, first of all, let's erase all this stuff that we don't do and say what we should do. What we should do is put everything on one side and 0 on the other side. So what we need to do is we got to add 24 over here to get 0 on the right side. If we add 24 on the right side, we got to add 24 on the left side. So we come up with 2y squared plus 19y plus 24 equals 0. So because these minus 24 plus 24 equals 0. Now we can use the zero product rule because we've got equals 0. Alright, so how do we do that? Next step is factor over here. Is it in descending order? Y squared, y to the first, y to the 0. Yep. Can we factor out a greatest common factor? 2y squared, is there a y in there? Nope. Is there a 2 in that one? Nope. So we're done. Do we need to factor out a negative 1? Nope. So now we've made our life as easy as possible, and let's start factoring. And I'm going to recommend again, we could use the AC method. We could say AC equals 2 times 24 is 48, find some factor pairs, and then replace that plus 19y with the factor pairs. But I'm going to say that because 2 is a prime number, and because we've got a plus here, the plus means it makes it a lot easier to factor, because we've only got plus, when we've got a sum here, the factors sum up to the same. They have to have the same sign. So let's try using our trial and error method. And if we use our trial and error method, we set up our factorization skeleton here, and we say, well, you know what, I've got to factor that a term here right here as 2 and 1. Then we take a look at the signs, and we could probably look at the signs first. Because this is a sum, then these signs have to be the same. So they sum, they either have to be both positive, both negative, they have to both add up to a positive number here, so it has to be a positive and a positive. And now we just play with the factorization of positive 24, or just 24 because we've assigned the signs already. So 24 factors into, well, 24 goes 1 and 24, 2 and 12, 3 and 8. And usually I try to start somewhere in the middle, because if we put 24 in here, 24 times even the 1 is going to be 24, and that's too much. 12, we could go with 12 if we put, let's see, I'll replace this with blue. If I put 2 and 12 here, 12 times 2x, and again, we've got to remember we've got to multiply the inside terms and the outside terms together, add those up to get to plus 19. 12 times 2 is 24x. Oops, sorry. This should be a y. Hang on a second. This should be a y. We're using y's here. Sorry. I should be wiser when I use my variables. My apologies for the bad pun and for the mistake. All right, so now if I'm looking at this, I'm saying, well, I'm trial and erroring with 12, 2 and 12. If I put 2 and 12 here, 12 times 2y gives me 24y. Too much. Even if I put 12 over here and I put, let's see, I make the small eraser and I say make that a 2. Let's go here and make that a 2. 12y, 12 times 1y gives me 12y, plus 4y is 16y. Not quite enough. So 2 and 12 doesn't work, so we eliminate that one. Go up here and erase. Say 12 doesn't work and 2 doesn't work. How about 3 and 8? That would be the next factorization. So let's try 3 and 8. Let's see, I want to get close to 19, so let's put an 8 over here and a 3 over here. 3 times 8 gives me 24. 3 times, if I do the inside and outside terms, 3 times 1y is 3y. Outside terms, 8 times 2y is plus 16y. And sure enough, 16 plus 3 gives us 19, and the y's are the correct variable. All right, so now that we've factored over here, we can probably double check our factorization and make sure that we've got this correct. 2y, by using the FOIL method, 2y times 1y, 2y squared. That's our first. Outside and inside, add up over here. We did that already. 16y plus 3y gives me 19y. Last terms are 3 times 8, 24. Okay, FOIL, by using the FOIL method, we've determined that this is correct factorization. So now we say we use the zero product rule. We can use the zero product rule and say that either 2y plus 3 equals 0 or y plus 8 equals 0. And we solve these mini equations to get our solution. Subtract 8 over here, subtract 8 over here. And I've got y equals negative 8 as a solution. We'll double check in just a second. And over here there's a two-step equation. We subtract 3, and we get 2y equals negative 3, divide by 2, and we get y equals negative 3 divided by 2. So there's our two potential solutions. Let's go back and check. If y equals negative 8, y equals negative 8, negative 8 plus 8 is 0. 0 times whatever it wants to be, 0. That one checks out. How about this one? Y equals negative 3 halves. Negative 3 halves times 2 is negative 3, because the 2's cancel out. Negative 3 plus 3 is 0. 0 times whatever it wants to be is 0, so that one checks out as well. So there's our two solutions. And again, I'm asking you to solve the quadratic equations. I gave you the quadratic equation. We had to make sure that we put everything on one side, 0 on the other, factor, and then one of these is equal to 0. Either that one equals 0 or that one equal to 0. Solve the solution, or solve the mini equations, and we've got a solution. All right, make sure you write your notes, take your notes, have taken notes, write down the homework assignment, homework question, I guess, and then take a picture, send it into my Dropbox, and we'll see you tomorrow.